Welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all. Welcome to episode 6 of the Solocasts of Firecode Tech. In this episode, we're talking about sprinkler basics. So I wanted to intro the conversation about sprinklers and really start diving into this technology. But before I take a look at the codes and standards and really go full bore on how to determine when these systems are needed and how to install them, I wanted to talk about some of the system essentials or the extreme basics. I know this is going to be too elementary for some of my listeners, probably a large portion, but I think it's important to have a rock solid understanding of the foundations of sprinkler systems, and maybe this will be informative for those who don't have as strong of a fire suppression background. To start off with, the standard for installation for sprinklers is NFPA 13. So in the US and in a lot of other parts of the world, NFPA 13 is the standard document to determine the installation features and design requirements for a sprinkler system. Now, this doesn't tell you when these systems are required, and so I'm not going to go into that for this episode. That's something that I will dive into further at a later date, but this is going to be more about system component basics and architecture and features of fire sprinkler system components. So yeah, that's kind of a preface for some of the content you're going to hear about. And NFPA 13 is the National Fire Protection Agency's standard for the installation of sprinkler systems. So I realize I didn't say that still. So in order to give us a basis or a rock solid fundamental base, I want to start with some definitions about a sprinkler system and what that is. Let's take a look at 3.3.205 sprinkler definitions. More specifically, the first definition in this category, titled automatic sprinkler. This definition says a fire suppression or control device that operates automatically when it's heat activated. Then it goes on to say the element is heated to its thermal rating or above, allowing water to discharge over a specified area. So this is talking about the fundamental characteristics of a sprinkler and what we need to have in order to consider something a sprinkler. I'm going to plan to include a picture in the show notes, but the general characteristics of a sprinkler are a deflector, some sort of element to fuse or to break at a specified heated temperature, and then also a frame, if you will. There are a couple different types of sprinkler head, fundamental types. So there's many subcategories within these types, but I would say the main three categories are upright, pendant, and sidewall. These all refer to the orientation in which the sprinkler is installed. And so when we take a look at the orientation in which they're installed, you have to, there's easy ways to determine if the sprinkler is one of these types by visually inspecting it due to the shape and configuration of the deflector, which is the top piece of the sprinkler. So upright sprinklers will generally have a curved deflector in order to ricochet the water off of the deflector piece and redirect it downwards. Pendant sprinklers will usually have a flat deflector because of the dispersion pattern meant to deflect it downwards. And sidewall sprinklers typically have a like L-shape looking deflector. So this is ordered to kind of flatten the spray pattern out and to project it forward. And so I'll try to include some pictures in the show notes, but I just wanted to cover this first and foremost. And so there's a couple different things that you can tell just by looking at a sprinkler. Um, Generally, if you want to determine, so the hole in which the water comes out of a sprinkler head is called the orifice. And the orifice, there's standard orifice sizes. The most common is 5.6 K factor. So what does that mean? Why would you want to know when you have a certain size of orifice? Well, the size of the orifice and the pressure at which the sprinkler is activated determines how much water is released when the sprinkler is activated. And so there's a simple formula for determining the amount of flow that a sprinkler releases when activated by knowing these factors. And so the K factors range from much smaller than 5.6. The residential sprinklers are, I believe, in the 4 range. And then if you look at specific application storage sprinklers, they can go all the way up to 25.2 K factor. So what does that mean? Let's do a quick little exercise to determine at standard pressures what kind of water release that would be. So if we are determining flow, the equation that we need is the K factor formula, and this is Q equals K times the square root of P, pressure. So I did a little bit of back of the envelope calculations to take a look at what standard sprinkler at a 5.6 K factor with the minimum operating pressure of 7 pounds per square inch, 7 psi, and what kind of flow would that release. So it's important to kind of have these back of, these understandings of standard flow for when you're taking a look at preliminary hydraulic analysis. And so the formula we spoke about previously was Q equals K times the square root of P. So if you take 5.6 K and then you multiply that by the square root of 7, you get 14.8 GPM, or approximately 15 GPM. So this is the standard amount of water that you could expect out of one of the most common types of sprinkler heads available, the 5.6 K factor head. And so then I took a look at a 25.2 K factor head, which is one of the largest that I'm aware of. I took a look at a 25.2 K ESFR head, a Viking head, and then I took a look at a cut sheet. Couldn't find a minimum available working pressure on a cut sheet. It said to refer to NFPA 813. Took a look at NFPA 813 and took a look at a storage application for a ESFR sprinkler head at about 25.2 K factor. And so the minimum working pressure of the head in the ESFR scenario for this example was 15 psi. So I took 25.2 and I multiplied the square root of 15, and then I got approximately 98 GPM. And so the physical size of these sprinklers don't change that drastically, and you can see that we've over quadrupled the amount of water coming out of this sprinkler head. So from 15 GPM to almost 100 GPM, and this is 15 psi is low on the pressures that 25.2 K factor head could operate at. Could operate at 60 psi or maybe more if there were other applications. I'm not exhaustively looking at these pressure applications. So they could have quite a lot of water coming out of one of these sprinkler devices. So here's the definition of a sprinkler system in NFPA 13. I want to talk about this because it goes over the fundamental architecture pieces of a sprinkler system, and it is a good basis for everybody to know. And in fact, I can't tell you how many times that I've gone back and read this. Not too many. Sprinkler system 3.3.206. I'm looking at the 2019 edition of NFPA 13. It says a system commonly activated by heat from a fire and discharges water over the fire area that consists of an integrated network of piping designed in accordance with fire protection engineering standards and includes a water supply source, a water control valve, a water alarm, water flow alarm, and drain. The portion of the sprinkler system above ground is a network of specifically sized or hydraulically designed piping installed in a building structure or area, generally overhead, and to which sprinklers are attached in a systematic pattern. Wow, that is dense. So let's go over a couple of these specific parts so I can expand upon them because they're multifaceted. It says a system commonly activated by heat from a fire and discharges water over the fire area. So this brings up a situation in which I didn't even think about is you have systems, fire suppression systems that are manually activated, like the ones that I can think of would be I'm sure there are pre-action systems that can be manually activated, or deluge system could be manually activated. And so that's an interesting caveat with that statement. Says next sentence says that consists of integrated network of piping designed in accordance with fire protection engineering standards that includes a water supply source, a water control valve, a water flow alarm, and a drain. So here they just told you the fundamental pieces for what you need to call it a sprinkler system. A water supply. So if you have no water to put into the system, you can't have a sprinkler system. And so I want to dive into water supply analysis, but yeah, really we're just going over the definitions here. A control valve. So a control valve is basically a way to isolate the system, provide maintenance, or to do work on the system. And then they say a water flow alarm, which is a way to know when the system is activated. So for standard wet pipe systems, this would be a vane type water flow switch, which is essentially a paddle within the fire suppression piping that is moved by the flowing of water and then sends a signal to the fire alarm panel, or a pressure switch in the case of a dry pipe or a pre-action system. And then it says a drain, and so you have to have a way to get the water out of the system if you need to maintain it. If there was a false activation, in the case of dry action or pre-action, you need to drain it for maintenance purposes, so you have to have a drain. Something I think is interesting is they don't talk about backflow prevention, which is and is not a component of a sprinkler system, I suppose. You need one. You need one when you have a sprinkler system, but the physical sprinkler system is, like they said, a control valve, water flow alarm, a way to drain it, and water to supply the system. So it says the portion of the sprinkler system above ground is a network of specifically sized and hydraulically designed piping installed in a building structure or area generally overhead, to which sprinklers are attached in a systematic pattern. So here they reference the hydraulic calculation method as well as the pipe schedule method. It says that there is intentional sizing to these pipes. So I've really just breached the surface on what a sprinkler system is. And if you can't tell, for a quick recap, a sprinkler system is a combination of valves, piping, drains, and alarm devices that is utilized to put out a fire. And so there are a variety of situations in which these systems are required by code for whatever jurisdiction you're working in. And so really I just wanted to cover some of the very essentials on this topic, and I want to keep diving into the topic of what these systems are, their component architecture, and really just keep going on this topic. I didn't get as far as I thought I would on this first episode, but I think that just goes to show how deep the topic is and how broad it is. And I think I went on a tangent there about the K factor in the orifice and how much water you can flow, but I think that's interesting and important as well. So, hope you enjoyed this solo cast, and if you want to check out another episode of similar length about sprinklers, you can go check out the Patreon at patreon.com/firecodetech and hear another episode about sprinklers that's released right now. So go check it out. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.